Okay, I'll start again, and for those of us that were in this morning session, I talked about the the need for us to have a distributed network. I introduced the cloud computing for us, which I'm also going to show us the National Institute of Science and Technology, their platform. But now let's go back to where we were. I'm trying to make us understand is that uh, distributed system has a lot of architectures that they use out there. But we are trying to itemize just two architectures that according to the software engineering scope, we would adopt in this lecture. The very two outstanding architecture is this client server architecture and the distributed object architecture. Now, for the client server architecture, it's what is widely used out there, whereby you have a service, you have a distributed service which are called on by clients. Servers that provide that provide services are treated differently from clients that use the services. So what are we trying to say? Use those services as a billing. So what am I talking about? Like I explained in my last lecture, I said you can have solar panels spread around customers' premises. They have batteries that they are charging, and what you now do is to put a metering device in the building that as much power that it consumes, that is the number of data that is being consumed. So what you sell data for them, and that particular data, or maybe wattage, data in form of wattage, that okay, 100 watts costs 100 naira. Take for example. So you go home and load it on the metering device. When you load it on the metering device, as you are using each wattage from the charged battery, your money is reducing. So the device that controls that metering service is a client server architecture, or rather, it's on a client server architecture whereby the client is the device that is in the house. It can be a thin client or a fat client. We'll get to that if the time permits. So you have that kind of architecture. Then we also have another type of architecture which is called distributed object architecture. In this case, no distinction between clients and servers. Any object on the system may provide and use services from other objects. Take, for example, you have a surveillance network whereby every camera is a node, and depending on what is being tracked, each camera that has the identified individual or object takes over the system. So we have applications already in the market with that kind of architecture. So let's look at the next slide. Now we now have what we call the middleware. The middleware, these are softwares that manages and supports different components of the system. In essence, it sits in the middle of the system. Now, the middleware is usually off the shelf rather than specially written software. And examples are transaction processing monitors, like I explained earlier on, that what causes that the software that ensures that the wattage, the right wattage is being used, and then the amount is being debited. And you can refer to maybe a radio server somewhere. So all these are examples of middlewares that vendors normally use in order to provide a distributed system. So that thing that does transaction is what we are talking about here. We also have data converters and we have communication controllers. Now, the next architecture we should look at is the microprocessor architectures. Now, like I said before now, in a distributed system, most time, we normally use, or rather, most times, a single processor device is being displayed in a unique environment. And the first thing we need to understand is that it uses the simplest system model, whereby an array of processors are all connected together via a network. And the second thing is that the system composed of multiple processors, like I said earlier on, which may but need not be executed on different, which may execute on different processors. So, like I said, an array of processors that the system will use in high execution. Then next thing also to take note of is that the architectural model of many large real-time system is what this microprocessor uses. It uses multi-processor. That the model they are usually deployed on large real-time systems. That's one of the features. And lastly, distribution of process to processor may be pre-ordered or may be under the control of a dispatcher. We are going to see briefly, take for example, the the way traffic light is being controlled. Now you can see that in this place we have different sensors that is taking the traffic and the speed of the vehicles and knowing getting input from the environment. Now these sensors come into a sensor control process that is being controlled by the display process. Now this display process is actually computed by the operator consoles. Now this happens over the traffic flow processor, and this section is actually referred to as the traffic flow processor. And that goes now to the processor that controls the street lights themselves. You can see that three types of processors are there. This is just the way they relate in the traffic light. But you can have multiple of these all tied together by operator consoles. Now you can see that for us to get a unit to control a set of traffic lights, you have the sensor processor, the traffic flow processor, and the traffic light control processor. Now these three processors work in synergy in order to control the traffic light.